Today we are reviewing integrals involving exponential log functions and inverse trig functions. So remember, integral of e to the power x is e to the power x, just like derivative of e to the power x is e to the power x. Integral of e to the power u du, where u is a function of x, u is a function of x. If u is a function of x, the integral is going to be e to the power u over u prime. Earlier, when we did the derivative, we multiplied with the derivative of inner function when we applied the chain rule, but when we do integration, we divide with the derivative of inner function. So here's a couple of examples. Example number 1, we are going to look at integral of e to the power 3x plus 1. So in this case, it would be just in e to the power 3x plus 1 divided by the derivative of u. Derivative of 3x plus 1 is 3 plus a c. Okay, next example looks like it's 5x e to the power negative x squared. So in this case, there's no product rule for integration. So we can let negative x squared be u, negative 2x dx be du, and I can say x dx be negative 1/2 du. So when we are ready to convert, I can pull the 5 out. I can pull the 1/2 out. 5 times half can be pulled out. 5 times half is out. 5 times half. 5 times negative half. Negative is also there. And then x dx will be du. X dx is du. And 5 is already out. This would be e to the power u. Okay, so that integral is going to become, we convert it into e to the power u. So that would be negative 5 halves e to the power u plus c, which is negative 5 halves. E to the power u was negative x squared plus a c. Write it, negative 5 halves e to the power negative x squared plus a c. Okay, next example, we have e to the power 1 over x divided by x squared dx. So again, you got to be clever. You got to think about u is a function whose derivative is sitting next to it. So if I let 1 over x be u, then negative 1 over x squared dx will be du. If I do the derivative with respect to x, then it would be negative 1 over x squared would be equal to du over dx, and then we can isolate the du from here. Okay, so 1 over x squared dx is equal to negative du, and we are ready to convert this integral e to the power u du, and rest everything went into, this was my du. So integral will be negative e to the power u plus c, which is negative e to the power u was 1 over x plus a c. And that's it. Don't forget to go back to x's at the end, because your problem didn't have u's in the beginning, so you cannot leave your final answer in terms of u's. If you have a definite integral, then there's no need to go back to x's. You can change your bounds to the u bounds and just go from there. Okay, let's check out the next example. So we have number 4. We can let cosine x be u, sine x dx be du. Cosine x be u, sine x dx would be negative du, because the derivative of cosine x is negative sine x. Sine x dx be negative du. I can adjust the negative sign on the right hand side. So here we are, and we are ready to convert this integral into u integral e to the power u du. Integral will be e to the power u plus c, and that's going to equal e to the power u plus c, which would be negative e to the power cosine x cos x plus a c. All right, here is example number 5, the next example. So looks like the derivative of bottom is sitting on the top, so derivative of denominator is sitting in the numerator. So if I call 1 plus ex to ex as u, then e to the power x dx will be du. E to the power x dx will be du. Okay, so here we are. We are ready to convert this integral into u integral. The whole numerator is du, and we have u over here. Now we also need to change the bounds. So let's look at when x is 0, u would be equal to 1 plus e to the power 0, and e to the power 0 is 1, so u would be 2. When x is 1, u would be equal to 1 plus e. Okay, so 2 to 1 plus e, u to the power negative 1 du. What's the integral of u to the power negative 1? How do we find the integral of u to the power negative 1, or 1 over u? Let's just leave it as 1 over u. I think it's better to look at it as 1 du over u. So that integral is going to be natural log of u, and then we have the bound from 2 to 1 plus e. Okay, natural log of 1 plus e minus natural log of 2, and that's going to be our final answer and product here. Now let's look at example number 6. Example number 6 looks like a bit tricky because I don't have the derivative of bottom sitting on the top. Derivative of denominator is not in the numerator. So what we can do here is, let's try to isolate the two fractions and see if that takes us anywhere. 2 over e to the power 3x dx plus e to the power x over e to the power 3x dx. Okay, now integral of 2 e to the power negative 3x dx plus integral of e to the power negative 2x dx. Now from here we can just do two separate integrals, and that is going to become, when we do the integration here, this will be 2 over negative 3 e to the power negative 3x plus minus, actually would be negative sign because we're going to be dividing with negative 2, e to the power negative 2x divided by 2 plus a c, and that'd be all for this problem. Next we're going to look at the integral of natural log. Other than e to the power x, if your base is not e, what's going to be the integral? So if your base is b to the power x, the integral will be b to the power x divided by natural log of b. And for example, so if you were doing integral of 3 to the power x dx, it would be 3 to the power x over natural log of 3 plus a c. And same if you have the integral of 1 over x dx, that's natural log of absolute value of x plus c. Absolute value of x, just so that we make sure that there's no domain restrictions with the natural log function. All right, let's look at a couple of examples. We have 2 over x dx, so I can pull the 2 out, and this would be, if I pull the 2 out, it would be 2 natural log of x plus c. We can put the absolute value bars around x. If your problem states that x is greater than 0, then there's no need to put the absolute value bars. You can ignore the bars. 4x minus 1 is in the denominator. How do we do the integral 1 over 4x minus 1? Well, can we do the u substitution? Can we let 4x minus 1 be the u, and then 4 dx will be du, and dx would be 1/4 du. Okay, so 1/4 du over u, 1/4. Now that would be natural log of 1/4 du over u, 1/4 natural log of u plus c, which is 1/4 natural log of 4x minus 1 plus a c. Right, next 2x over x plus 1 squared. So it looks like in the denominator I have x plus 1 squared, and the derivative of bottom is not sitting on the top. So I'm going to try to let x plus 1 as u, and then dx would be equal to du. And I can also say from here that x would be equal to u minus 1. So I'm ready to change this integral. This would be u minus 1 in the numerator. I can pull the 2 out. 2 is not needed. 2 is a common, not a common, but a constant factor, so we can pull it out. 2 is out, and x can be replaced by u minus 1, and then we have u squared du. And that leaves me with, we can separate into two integrals and then go from there. All right, so 2 is out, and I can isolate the two integrals. U over u squared would be 1 over u du minus u to the power negative 2 du, and that is going to leave me with 2. Natural log of u minus u to the power negative 2 plus 1 is negative 1. And we will also divide with negative 1, which will become plus sign here and plus a c. One last step that's necessary is to go back and replace everything with the x's, like we had x in the beginning. So it would be 2 natural log of okay, so lack of space, I'm gonna go write the final answer here. We have 2 natural log of u was x plus 1 plus 1 over x plus 1 plus a c, and that's it. That's the end product. Right, we have one more example here. I'm gonna clear some work over here to make some space for the next problem. We have integral of 1 over x natural log of x, so we can let natural log of x be the u, 1 over x dx will be du, right? So we are ready to convert this integral into the u integral. That would be 1 over u du. And we need to change the bounds as well. So when x is 2, u would be natural log of 2. So that's the bound, natural log of 2. And when x is e, u would be natural log of e, which is equal to 1. From here, we can perform the integration. So that would be natural log of u, natural log of 2, natural log of 1. So we're ready to write the final answer. Natural log of 2 minus natural log of 1. Natural log of 1 is equal to 0, so we don't need to write this part, and that would be our final answer. And let's see if it's going to be positive or negative. I think it's going to be, there was a minus sign here. Oh, when I plug the bounds here, let's go back a step. When I plug the bounds, we need to plug the upper bound first. Natural log of 1 minus natural log of 2. So this is going to be 0, and our final answer would be negative natural log of 2. All right, let's look at some inverse trig functions, integrals, and derivatives. Remember the rules for derivatives? I actually only remember the 3 of them. Sine inverse x derivative is 1 over square root of 1 minus x squared. I also remember the tangent inverse x and the secant inverse x. And then the remaining co-functions, if I remember the sign, I only need to put the negative sign in the front to get the cosine. If I remember secant, I only need to put negative sign in the front to get cosecant. If I remember tangent, I only need to put negative sign in the front to get cotangent. Okay, and now we're going to talk about integrals here. Integral of 1 over square root of 1 minus x squared dx is sine inverse x plus c. Integral of 1 over square root of 1 minus x squared dx is negative cosine inverse x plus c. Integral of, okay, so 1 over, so there's a typo over here. This is going to be 1 over 1 plus x squared dx is tan inverse x plus c. So remember these integration formulas. Now integral formulas. Earlier we looked at the derivative formulas in the last chapter, but now we're looking at the integral formulas. Okay, let's see a couple of examples, and also remember the domains and ranges of inverse trig functions. Here's my first example. Evaluate the integral 0 to 1 over 1 plus x squared. So I can see this is directly tangent inverse x, and the bounds are from 0 to 1. So tangent inverse 1 minus tangent inverse 0. Tangent inverse 1 is pi over 4, and tangent inverse 0 is 0. So pi over 4 is going to be my final answer. Now let's check out a couple more examples involving inverse trig function number 2. Here I'm going to try to utilize a u substitution, but before that, I'm going to pull out a 3 square root of 9 from the square root. Okay, so if I pull out a square root of 9, I'm left with 16 over 9x squared dx, which is 1/3, 1 over 1 minus 4/3 x squared dx. So we can let 4/3 x be u, 4 over 3 dx be du. Okay, dx would be equal to 3/4 du. All right, so 1/3, 3/4 du over 1 minus u square. So what's the integral of 1 over 1 minus u square? Square root of 1 over 1 minus u square. We just looked at the integration formulas, and that's going to fall under sine inverse x. It looks more like sine inverse x. So this would be sine inverse u, 1/4 sine inverse u, and there's no bound, so there's a c. 1/4 sine inverse, the u was 4/3 x. 4/3 x plus a c. All right, so that's one thing. Next, we have number 4. So this one looks like, because we have 16x squared in the front, this is going to be a secant. So I'm going to have to do substitution for secant. So what I'm going to do is I'm going to start by 1 over 2 divided by 2 root 2 dx over, I can pull the 6. No, I'm not going to pull the 16 out because it's going to leave me with a fraction, and I do need to keep a 1 over there. So I'm going to write it as 4x squared minus 1. I'm going to let 4x be u and 4dx be du. That means dx will be 1/4 du. So when I convert this integral into the u integral, this would be du, and 1/4 goes in the front, square root of u squared minus 1. And that's going to be, there is an x in the front as well, which is u. 1 over u, and then square root of u squared minus 1. And that's what we have for secant inverse x. If you look at the integral of secant inverse x, there is 1 over x, square root of x squared minus 1. I'm just assuming in all these problems, if it's not stated, the x is positive only. So I have directions that says x is positive only. I'm not going to worry about absolute value bars. All right, so this is going to be 1/4 secant inverse u, 1 over 2 root 2 to 1/2. So simplifying this a little bit, let's see where does it take me. I'll just leave this part plugging the bounds in for you. Use a calculator and go from there. All right, next problem, x over x to the 4th plus 1. How are we going to tackle this problem? Let's go ahead and check. Can we replace x squared? So we can call it, okay, so let x squared plus 1, no, that wouldn't work. So let x squared be u, 2x dx will be du, or x dx will be 1/2 du. So when I'm ready to change this integral into the u integral, I'll have du on the top and u squared plus 1 on the bottom, which is 1/2 tangent inverse u plus c. And we need to replace the u by whatever u was in the beginning. That's it. Next problem. Looks like it's going to be a secant, but I don't have x squared inside, so it's a bit tricky. Let's try in this case. Because I don't have, I have x squared minus 1 inside. I need to have x squared in the front for this to be a secant. So I'm going to multiply numerator and denominator by x, both top and bottom by x. So it would be x dx over x squared, x to the 4th minus 1. I'm going to make it like a secant. It's not secant right now. Now if I let x squared be u, 2x dx will be du, or x dx will be 1/2 du. So that is going to change my integral. Looking over here, x dx would be equal to 1/2 du. So I can pull 1/2 out, du there. And x squared is u, square root of u squared minus 1. Definitely a secant, inverse u plus c. We don't forget to change the u back to whatever we called u in the beginning. The u was x squared, secant inverse x squared plus a c. That's end of this video. So today we reviewed some inverse trig function integrals, some exponential and log